So today I will be trying to solve one problem. Okay. So what I want is I want you people to just practice whatever I have solved. Okay. So that it helps you in understanding the things. Okay. So before, so 5 minutes is over. I'm going to lock up the meeting now. Yeah, done, locked up. Okay. So now no one can join. Now, before going to solve the problem, let's understand what we have learned in the previous class. Just I will brief you about how to go about the problem. Okay, so I will go through this. So yesterday we have seen one problem. So first, what is the first procedure to solve this one is, okay, get the equations. So this is the equations what we have developed. Once we have developed this particular motion equation, or equation of motion, get it in the matrix format. What is that matrix format? Mx double dot plus kx is equal to 0. This is the matrix format. Then this is M is called as mass matrix and K is called as stiffness matrix. Once we know that particular part, then we have to convert this one. So how to convert that? Very simple. X is equal to capital X sin omega t, which you have learned in the introductory classes. Okay. So once we know that one, then what we do is we convert that x double dot into what you call minus omega square into sin omega t. This is what I am going to get. Then we are going to remove the sin omega t. We are going to get in this particular format. Okay, so this is the format what I am going to get. Okay, so once we are done with this particular part, okay, so what we have to do is we have to combine that one. We have to combine the M matrix and K matrix, combine that one. Okay, then get the determinant out of this. Okay, so we have to get the determinant. Once we get the determinant, solve for that one and solve for the principal. So this is how we start for what you call working on this particular problems. So today, okay, so we'll start one problem. So the problem which I have got here, okay, so this is the problem which I have got here. Okay, you can check with this. Okay, 3k, kk, 4m, 2m, and m. Okay, so let's hope you are seeing this. Okay, so let's start the problem. Okay, I will stop my video. Okay, Baba. So let's start with this today's problem. Okay, so let's start with today's problem. Okay, so to start with, for the first thing, we have to get the equation of what you call motion, right? We have to get the equation of motion. So how to start? What is the procedure? You already know. We have got 3 masses, 1 DOF, so automatically it becomes 3 DOF system. So when there is a 3 DOF system, the number of equation of motion what I am going to get will be what you call 3 simultaneous equations I am going to get. Okay, so let's start with this particular problem here now today. Okay, so I will start with 4m, please. Okay, equation of motion. Just I am repeating what we have done, but still okay, no problem, so that you can understand. 4m. So now, okay, so he hasn't given x1, x2, x3. We will write this one. This as x1, this as x2, and this as what? X3. Okay, so 4m x1 double dot is equal to minus 3k x1 minus 0 minus k, right? x1 minus x2, right? So this is my what you call equation. 4m x1 double dot minus, okay, so now if I rewrite this, this becomes 4m x1 double dot minus 3k1 minus k into x1 minus x2 is equal to 0. Again, if I simplify, I'm going to get 4m x1 double dot. You can check it out here. This becomes, oh, sorry. This is plus, this is also plus, sorry. Okay, plus 4k1, correct or not? This and this will get added up, minus kx2 is equal to 0. Okay, so this is my equation number 1, right? Similarly, I will go for the second mass. What is the second mass now? 2m x2 double dot is equal to minus k into x1 x2 minus x1 minus k into x2 minus x3, right? So this is my second equation. Simplify this. 2m x2 double dot plus k into x2 minus x1 plus k into x2 minus x3 is equal to 0. So if I rewrite this, I'm going to get 2m x2 double dot 2m x2 double dot, then what is this? X1, we will first take it x1. What is that? Minus k into x1, correct? Then plus 2k x2, correct or not? Then minus k into x3 is equal to 0. This is my second equation, right? Then we will go for the last one. What is the last? mx3 double dot is equal to minus times of k into x3 minus x2, correct? If I write this, mx3 double dot plus k into x3 minus x2 is equal to 0. That gives me mx3 double dot minus kx2 plus kx3 is equal to 0. This gives me equation number 3. Okay, so now I am going to take these all 3 equations and rewrite this, right? What is that? What it become? 4 mx1 double dot plus 4k1 minus kx2 is equal to 0. Then 2mx2 double dot minus kx1 plus 2kx2 minus kx3 is equal to 0. And lastly, what I have got here, mx3 double dot minus kx2 plus kx3 is equal to 0. This is my equation number 4. Okay, please cross check. 4m x1 double dot plus 4k x1 here, 4k x1 minus kx2, 2m x2 double dot minus kx1 plus 2k x2 minus kx3. Okay, mx3 double dot minus kx2 plus kx3 is equal to 0. Okay, so this is my equation. As I have said earlier, now we have to split this one into the format of what we know very well. What is that format, please? M x double dot plus k into x is equal to 0, right? So what happens now? If you see here, my equation becomes, I will this one, and this one. Correct or not? 4m, 2m, and m. 0, 0, 0, 0, 0, 0. Right? x1 double dot, x2 double dot, x3 double dot plus, okay, what is that? 4k and then minus k, 0. Next one, minus k, 2k, minus k, 0, minus k, k, and this becomes x1, x2, x3 is equal to 0. So this is my, what you call, equation in this field. So if I check it out like this is called as mass matrix, right? And this is called as stiffness matrix, right? This is called as mass matrix and this one is called as stiffness matrix. Now what I have to apply? I have to apply, we know, as we know, small x is equal to capital X sine omega t. Then automatically x double dot will become minus omega square into capital X sine omega t. So this I have to apply to this particular, what you call, equation. So for the above one. So if I apply for the above, what I am going to get in this particular one, right? You know that one. So automatically my, okay, this one will become 4m 0 0 0 2m 0 0 0 m. This will become minus omega square capital X1 sine omega t minus omega square x2 sine omega t minus omega square x3 sine omega t plus 4k minus k 0 minus k 2k minus k minus k k 0. Here this becomes what? x1 sine omega t, x2 sine omega t, x3 sine omega t is equal to 0, right? So this is the equation what I have got here, right? Then if I segregate everything and sine omega t will go off, the one which I am left out with by adding this, what I am going to have is 4m, correct? 4m minus 4m omega square 0 0 0 minus 2m omega square 0 0 0 minus m omega square. Correct, Nababa? This is what I am going to get. Then you will have x1, x2 and x3 plus, right, this equation remains the same here. Which one? K minus k 0 minus k 0 2k minus k k x1 x2 x3 is equal to 0, right? So this is what. Now x1 x2 x3 everything is common. I will club this particular part. You can check it out. I will try to club this one. Okay, so when I try to club this particular part, that what I am going to get is 4k minus 4m omega square, right, minus k 0, again here 0, 2k minus 2m omega square minus k Oh, sorry, I did a small mistake here. This has to be minus k, 0, minus k, and then k minus m omega square, right? x1, x2, x3 is equal to 0. So this is what I have got now here. Now what I am going to do. So for the given data, what I have to do is, now this characters equation, what I have got here is I have to expanding the determinant now. So what is that I have to do now? I have to get the determinant. So what is it? 1 is equal to 4k minus 4m omega square minus k 0 minus k 2k minus 2m omega square minus k, right? 0 minus k minus m omega square. Okay, this is equal to 0. Now next part, I have to expanding the determinant, the characteristic equation becomes, okay, so what is the one which becomes now? Oh, I have to expand this, right? Okay, so if I try to expand this, I will get, please check it out, 4k minus 4m omega square, open the bracket, again 2k minus 2m omega square into k minus m omega square, close the bracket, minus k square, close the bracket, plus minus k into minus 1, correct or not? 2 minus k minus m omega square, so minus 0 is equal to 0. So you can cross check this one, right? So then if I see, what I will do is I will take this 4 inside. I will take this particular 4 inside here. Okay. So my equation becomes k minus m omega square, right? 8. I can take 2 outside because it is common here too. I can take 2 outside. Then I multiply this one by 4. I will get 8 here. K minus m omega square whole square. Hopefully you understood this k over my m omega square, this k m omega square. I have taken this 2 out here. 4 into 4, this multiplies when this one, it becomes 8 k whole square minus 4k square, right? This 4 has to be again multiplied with this k also here, correct or not? So this 4 has to be multiplied with this also, 4k square, right? Minus k square into k minus m omega square is equal to 0. So if you check it out here, here and here, both the cases, okay, what is this? K minus m is what? Common, right? So what I can do now here, very simply, I can say k minus m omega square I will take outside. Then the equation becomes 8 m omega to the power of 4 minus 16 mk omega square plus 3k square. If I solve this one, if I try to get this particular equation, okay, I'm going to get this particular equation, right? Okay, so now how many roots I'm supposed to, since it is a 3DOF system, I should get 3 frequencies. right? What are those frequencies? Omega 1, omega 2, and omega 3, right? So very simple. What I will do is the first root of the frequency, okay, equation is obtained from easily you can check it out, correct? Which one? A minus m omega square, correct? So automatically what happens? Equate it to 0, then omega first root. I'm talking about what? First root. Okay, omega is equal to root k by m. Correct or not? If I solve this particular equation, it becomes root k by m. Okay, how about the second root now? For the second and third root, I have to use this particular equation. Okay, for the second and third root, I have to use this equation. So, how to get that one? Very simple. To get other two roots, what I will do is, I will use the equation, which one? 8m square omega to the power of 4 minus 16mk omega square plus 3k square is equal to 0. You can cross check. You can cross check here. 8 omega square minus 16mk square plus 3. You can cross check here. Right? So I have taken this. Right? Then I will try to solve. So if I solve, it's very simple. What I will do is, I use little bit of this one here, dividing out by what? 8m square whole equation. What I am going to get here, you can check it out. Omega to the power of 4 minus 2 k by m into omega square plus 3 by 8 k by m whole square is equal to 0. So this is the equation what happened. So solving, omega is equal to root of 0.21 k by m and omega is equal to root of 1.79 k by m. Now, one thing which you haven't noticed here is, I have got all the three, what you call omegas here, right? This is one omega, this is another omega, and this is, but I never marked omega 1, omega 2, omega 3. The reason for not marking omega 1, omega 2, omega 3 is, at the start of this particular chapter, if you remember, okay, I will go back to the first one here. I'll go back to the starting one here. Yeah, here it is. I hope you remember this. Okay, now on that particular I told, the lowest frequency is called as what? Fundamental natural frequency. Okay, hopefully you have understood now. The lowest frequency among all the frequencies is known as the fundamental natural frequency. That means always omega 1 will be the lowest frequency, that is the least one among all the one. Now, if I take, okay, all the things here, now let's come back. If I take all the ones here, I have got which one? This one, this one, and this one, right? I have got what you call 3 frequencies. But which one I have to make? Now you tell me. Now you can just think about yourself. Which one is omega 1, omega 2? For that particular reason, I never marked omega 1, omega 2, omega 3 because I am not sure. After getting omega 1, omega is equal to root, what do you call, k by m. I never come to know whether we have got less than root k by m or greater than k by. I don't know about that, right? So for that particular reason, I thought of what you call waiting for that particular part. Okay. Now what it is that? So I have got 3, right? So when I have got 3 here, okay, omega is equal to root k by m. Omega is equal to root of 0.21 root k by m. Okay. So these are the things what I have got here, right? So when you check it out, this particular part, let's see which is the first one, which is the last one. Okay, so let's start. As you know here, easily I can make out. This will be your first one, correct or not? This will be your first one, right? Next, which one is next one now? This will be your second one, and this will be your third one. On what basis? If I take the root of omega 1 is equal to omega 1 is equal to, sorry, if I take the root of 0.21, okay, if I take the root of 0.21, just I will calculate here, 0.21. The answer what I am going to get is 0.45 root k by m, right? Similarly, if the next one will be omega 2 is equal to root k by m, and omega 3 is equal to, if I take the root of 1.79, I'm going to get 1.33 root k by m. This will be now the 3, what do you call, fundamental, what do you call, the 3 roots what I have got, and in this particular one, this will be my, what you called as fundamental frequency. Okay, this will be my fundamental frequency. For that particular reason, okay, I never written what you call previously omega 1, omega 2, and omega 3. So now I have written it separately here. Omega 1 is equal to 0.45 root k by m. Omega 2 is equal to, what do you call, omega 2 is equal to root k by m, and omega 3 is equal to 1.33 root k by m. Okay, so this is the problem which we try to solve. Hopefully, okay, you have understood this problem.